Hello, welcome to Maths and Science Professor channel. You have been presented with the two equations, equation 1 and equation 2, and you have been advised to use Cramer's rule to solve the set of equations. If you have a set of equations with more than one unknown, you can then use a Cramer's rule to solve the set of equations. The equations we have can be put in a standard form, and we can have a1x plus a b1y is equals to d1, and we can also have a2x plus b2y is equals to d2. This is the standard form of our two equations, and we can put this in matrix form, and then we can have a1 b1 a2 b2 in matrix form like this. We can also have d1, and then we have d1 and d2. How do you solve a set of equations with while using Cramer's rule? Now, to solve this equation, to find the value of x, the value of x is dx over d, and the value of y is dy over d. If you had more than one unknowns, for example z, t, and then the value of t will be dt over dt, dz will be dz over d. How then do you go and find the value of d? D is the determinant of our matrix A1, B1, A2, B2. And our A1, B1, A2, B2, as in our equation, is 3, negative 2, 4, negative 3. This is our matrix A1, B1, A2, B2. You then go ahead and you find the determinant. 3 times negative 3, that will be negative 9, minus 4 times negative 2, that is negative 8, and then you find your answer to be negative 1. That is the value of our d. Our d is equals to negative 1. Let's go ahead and find dx. What is the value of dx? Dx is d1, d2, and then you will have b1, b2, and in our equation d1 is negative 14 and d2 is 11, b1 is 4, and b2 is negative 3. Now you find the determinant of this matrix, and then you will have negative 14 times negative 3. This one you subtract 11 times 4. What then will you have? You will have negative 14 times negative 3, that is 42. 42 minus 11 times 4 is 44, and your answer is minus 2. That is our value of dx. Our value of dx is minus 2. I hope you can see through and follow what we have done to find our value of dx. We can also go ahead and find the value of dy. Our dy is a1, a2. We now replace the column of y with d1 and d2, d1 and d2. That is a1. What is our a1? Our a1 is 3, our a2 is negative 2, and our d1 is 11. D2, d1 is a negative 14. This is negative 14, and d2 is 11. You then solve find the determinant for 3, negative 2, negative 14, 11. This is a 2 by 2 matrix. To find the determinant, you multiply the main diagonal, and then you subtract the minor diagonal. You will have 3 times 11, then you subtract negative 14 times negative 2. This will be 33 minus 14 times 2 This is 28. Negative 33 minus 28 will give you 5. We said that the value of x is equals to dx over d. We found out that dx is negative 2 and d is negative 1. X is 1. The value of y is equals to dy over d. Our dy was 5 and our d was negative 1. The value of y is negative 5. The value of x, we have used Cramer's rule to find out the value of x and y, and we have found out the value of x is 1 and the value of y is negative 5. If you substitute the value of x and the value of y in our equation, x is 1, 3 times 1 is 3, plus y is negative 5. 4 times negative 5 is 20, is negative 20, and then you have 3 times 1 is 3. You should find your answer to be negative 14. If you have 20 here, and then you have x, our x should be, no, we have messed up in finding the value of x. We said that the value of dx is negative 2 and this one is 1. You can see here we did a mistake here. The value of x is 2 and the value of y is 5. The value of y is negative 5. If you replace the value of x and y in our equation, our x is 2. 2 times 3 is 6, plus 4 times negative 5 is negative 20. You add 6 plus negative 20, you find your answer to be negative 14. Likewise, if you substitute x and y in our next equation, x is 2 times negative 2, that is 4, minus 3 times negative 5, that is 15. 4 minus 15, what do you find? 4 minus 15, you find your answer is 11. We have correctly found the value of x and y. It is 2 and negative 5 using the Cramer's rule. Let's see our second example. Let's look at our second example of equations. We have x plus 2y plus 3z is equals to 17. Equation 2 is 3x plus 2y plus z is equals to 11. X minus 5y plus z is equals to 15 to negative 5. Now we can have our set of equations in a standard form, and then we can have a1x plus b1y plus c1z is equals to d1. We will have a2x plus b2y plus c2z is equals to d2. We will also have a3x plus b3y plus c3z is equals to d3. In matrix form, we will have a1, b1, c1, a2, b2, c2, a3, b3, and c3. We also have d1, d2, and d3. Now, to find the value of x, the value of x is dx over d. The value of y is dy over d, and the value of z is dz over d. How then do we find the value of d? The value of d is a1, b1, c1, then we have a2, b2, and c2. We have a3, b3, and c3. we find the determinant of our 3 by 3 matrix. In our example, we have A1 as 1, A2 is 3, and A3 is 1. We have B1 is 2, B2 is 2, and B3 is -5. We have C1 is 3, C2 is 1, and C3 is 1. What we then do, we have our 3 by 3 matrix, 1, 2, 3, 3, 2, 1, 1, -5, 1. We find the determinant of this matrix. We can pick one of we can pick either a row or a column. Let's say we have 1, 2, 3. When you have 1, you can have 1. What do? You look at this row and then you cancel the column. What you remain is with this 2, -5, 1, and 1. And then you have 2, you will have 3, 1, and then 1, 1. We then have 3, 3, 1, 2, -5. What is the value? Plus, minus, plus. Let's have this. 2 times 1 is 2, minus 5 is 7. 2 times 1 is 2, minus 5, you find 7. So you will have plus 7. Here you have 3 times 1 is 3. 3 minus 1 is 2. 2 times -2 is -4. Here you have 3 times -5 is -15. -15 minus 2, you find -17 times 3. You have 51. 7 minus 4 plus 51. You have determinant as 54. Okay, you find we here is supposed to be -51, and then if you work out this one, if you work out 7 minus 4 minus 51, you find your answer as -48. Our D is -48. Now let's go ahead and find dx. In finding dx, we replace the value of a1, a2, a3 with d1, d2, d3. Our d1, d2, d3 is 17, 11, and -5. We have b1, b2, 3 remains the same, 2, -5, 3, 1, 1. Now you have 17. You will have, if you cancel this column and the row, you will have 2, -5, and 1, 1. Should be positive 17, and then minus 2. You will have 11 minus 5. You will have 1, 1, and then you have plus 3. You will have 11 minus 5, 2 minus 5. If you work out this one, you will have 17. 2 times 1 minus 5 times 17. You find out your answer to be 119. If you work out this one, you find your answer to be 11. If you have the main diagonal 11 minus 5 and then times -2, you will have -32. If you work out this one, you will have -135. If you solve this, 119 minus 32 minus 135, you find your answer to be -48. Now our value of dx, we come and write it here. Our dx is -48. This is our dx. We then go ahead and find our dy. In finding the value of dy, you will have a1, a2, a3 remain the same. You will have 1, 3, 1. And then b1, b2, b3 will change. You will have d1, d2, d3. You will have 17, 11, and -5. c1, c2, c3 will remain the same. You will have 3, 1, 1. You find the determinant of this matrix. You start by 1 plus 1. When you cancel the column and the row, you will have 11, -5, and 1, 1. You will have -17. Cancel the column and the row, you will have 3, 1. You have 1, 1, and then you have +3. Cancel the column and the row, you will have 3, 1, 11, and -5. If you work out this one, you will find 16, 34. This your answer becomes 16, and then here your answer becomes -34. Here your answer becomes -78. 16 minus 34 minus 78, you will have -96. Our dy, we come and indicate here. Our dy is equals to -96. We go ahead and find a dz. In finding dz, our a1, a2, a3, b1, b2, b3 will remain the same. c1, c2, c3 will change, and we'll have d1, d2, d3, d1, d2, d3. That is a1 is 1, 3, 1, 2, 2, -5, 17, 11, -5. If you express that one, we find the determinant of our 3 by 3 matrix. We'll have +1. You cancel the row and the column, you will have 2 minus 5. You have 11 minus 5, and then you have -2. Cancel the row and the column, you have 3 minus 1, 11 minus 5, and then you have +17. Cancel the row and the column, you will have 3, 1, 2 minus 5. If you work out this one, you will find 45. Find your answer here to be 45, and then you work out this one, you find -52. You find -289. You work out this one, 45 minus 52 minus 289, you have -192. Now the value of our dz is -192. Let's go ahead and find the value of x, y, z. The value of x is dx over d. We found out that dx was negative 48. We found out that d was also negative 48, and therefore the value of x is 1. The value of y is dy over d. What was our dy? Our dy was negative 96, and our d was negative 48, and then our y becomes 2. Our z will be dz over d. dz is negative 192, and our d is negative 48. Our z value becomes 4. Now, using Cramer's rule, we have found out the value of x to be 1, the value of y to be 2, and the value of z to be 4. If you substitute the value of x, y, and z in our equations 1, 2, and 3, you will find that x plus 2y plus 3z is equals to 17, 3x plus 2y plus 2 is equals to 11, x minus 5y plus 2 is equals to negative 5. We can try out and see. Our first equation, let's substitute the value of x. We'll have 1 plus 2 into 2 plus 3 into 4, and that one will give you 12 plus 4 is 16 plus 1, 17, meaning our value for x, y, and z are correct.